Hello everyone, this is Mr. Regner and this is Solving Percent Problems. I'm hoping that today I can show you how to solve percent problems in kind of an easy way. So I want to start off with a couple different methods and then one method that I think may be the easiest, perhaps. So my first two methods are actually visual. So we might have a problem. You might say, what is a percent problem? Maybe we want to know what 20% of 60 is. So I had to figure out what is 20% of 60. Now I could figure this out by actually making a diagram, which may help you. All right, so I'm going to start off with this diagram here. It's just a regular old bar, just a big rectangle, right? And if I think about 20%, again, 20% of this whole thing is one whole. 20% of that is going to be smaller. So there's my 20% line. And if I bring that all the way up to 100%, that's 40%, 60%, 80%, and then this would be 100%. I guess I could put my little percent signs there as well, just to make that super clear. Now, if I think about this, I'm trying to figure out what 20% of 60 would be. So I want to take that 60, and that's going to represent my 100%. That's all of it. 60 is all of it. That's 100%. So I need to break this down and figure out then what is 20% of that 60. Well, here graphically, we can see that it's going to be just this amount. We have to think, how can I take this total amount of 60 and break it down now into 1, 2, 3, 4, 5 parts? I'd have to take 60 divided by 5 to figure out the value of each part. Now, clearly, if you're quick at math, or maybe you just know that 60 divided by 5 is 12. So that means that each part here is 12. That's 12, that's 24, that's 36, that's 42, and then that would be 60. So 20% of 60 is 12. 20% of 60 equals 12. Again, a nice visual way to look at that, and some of you will enjoy that method, because no matter what our number is here, that's always going to be 100%, and then we can try to figure out what that fraction would be. Now 20%, that was kind of easy because that's counted by 20s to get up to 100. Some of your other numbers might not work out quite as well, or might be a little bit trickier. And so maybe that's not going to be best to use with those numbers. Let me try another one here. Let's try 30% of 30. Now, if I tried to make a bar graph with 30%, I'd have 30, 60, 90, and I'd be stuck, right? So that wouldn't work. Maybe I could go 10%. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And then my 30% line would still be there. So again, there's still ways that I could use that old diagram. There's another method though, and this one's making more of like a ratio table. Remember, this percent is really just a ratio. That 30% is the same thing as saying it's 30 out of 100, right? That's a part to whole ratio. Part to whole. So our part is 30. Our whole is 100. So all I need to do is take this percent as a part to whole ratio and figure out if it's 30% to 100 whole, 30 to 100, what would it be to 30 whole? So I'm going to put 30 down here and figure out then what is this going to be. Now, I can't take 100 and just get 30, right? Division is not going to be easy there, but I can do some math magic here by taking 100 and multiplying it to make it a bigger number, or dividing it to make it a smaller number. Now in the end, I want to end up with 30. So I'm actually going to take this number and multiply it times 3 to get 300. I'll do the same thing up here, multiplied by 3. 30 times 3, that's 90. So now I have 90 out of 300. Well, that's good, but I need to know what 30 is. Since I inflated to 300, I can easily make that 30 by dividing by 10. 300 divided by 10 is 30. So I'll do the same thing up here. Divide by 10. 90 divided by 10 is 9. That means 30% of 30 equals 9. Now those are two visual ways. I'll put this one back up here again. We've got the picture of it here. We can break it apart, kind of like a tape diagram. We've got the table. We learned about those when we were learning about ratios. But there's actually even an easier way. Now, let me give you another problem. I'm just going to make some numbers up here. Let's go with 82% of, let's say, 15. Oh my goodness. Now again, I could make a chart, I could make a table, to make that tape diagram if I want to, but there's an even easier way. You see, this fraction is kind of like, I have a visual here, kind of like this Lifesaver, or really any candy. Now, I could try to eat this right now. Chomp, 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 chomp. Oh. I would not taste that candy. It would taste actually kind of gross because it's wrapped up. In order to use this candy and get the most benefit from it, I have to unwrap it. The same is true for this 82%. I have to unwrap it, right? Once we unwrap it, now we can eat it. Good stuff. The 82%, we're going to unwrap it, and it's going to become either a fraction or a decimal. Now, you could turn this into a fraction, but I think most people would probably agree that turning this into a decimal is going to be the easiest way to use it. So I'm going to turn this into a decimal by dropping that percent, taking the decimal and moving it over 2 times to the left, right? We end up with 82 hundredths. This word of means times. We always think of means times in math. So we're going to convert that into a times sign, and I'll keep my 15 the same. Now I have 82 hundredths times 15. Well, that's just a regular old math problem. In fact, I can do that right here. So I'm going to take 82 hundredths times 15. I'm going to do the math. You might recall that when we multiply with decimals, we kind of ignore the decimal at first, and we'll bring it back at the end. So 5 times 2 is 10. 5 times 8 is 40, plus 1 is 41. Add my placeholder 0. 1 times 2 is 2. 1 times 8 is 8. Now I add them together. 0 plus 0 is 0. 1 plus 2 is 3. 8 plus 4 is 12. And now I'll bring back my decimals. Look, I have 1 place, 2 places, and 0 places. That means I need to put my decimal 2 places over. My answer here, 82% of 15, is 12 3/10. I'm just telling you, I probably would not have known that without doing this math. So the math is important. I'm not sure that the visuals there would have helped me, because that's kind of a weird, obscure number. So always know that the visuals can help you, but they may not always be the best route. In this case, we can always multiply. Let me show you a couple others here without doing the math, just kind of how to set it up. So again, pulling up some random numbers off the top of my head. 104% of 13. Did I just use 13? I didn't. Okay, good. So for this, it's the same thing as saying, convert this, 2 times over to the left. It's the same thing as saying 1 400ths times 13. We would get our answer. I could say 0.5% of 1001. That's the same thing as saying, move my decimal over 2 times to the left, 0.005, because I moved that decimal 2 times. So 5 thousandths times 1001. I could do 28% of 1. Crazy, right? Same thing as saying 28 hundredths times 1, which I think you know the answer to that. I could do 38.032% of 38.032, and that would be the same thing as saying, let's see, I don't even, this is a big number, 38032 times, I ran out of room on my paper, but you get the idea where I'm going here. It's the same thing. We're just converting percents to decimals, and then we multiply. You got to unwrap that before you can use it. Okay? Now it just becomes a regular old math problem. So be aware, yes, there are visual ways here that you can solve these problems. And I showed you those. But I think the easiest path is really just going to be to unwrap that candy. And that way you can use it. Unwrap the percentage. Turn it into a decimal, and then just multiply. So this should really give you a perfect start to solving these percent problems. Again, just unwrap your percent and you're on your way. But wait a minute, it's never quite that easy, right? What if we had a problem like this? 25% of something, an unknown number, is 40. Right? That's like saying if I used a variable here, 25% times x equals 40. Now I've got myself a little equation here. I can convert that 25% into a decimal. And again, if I have a number next to a variable, we assume we know that means times. So 2500ths times x equals 40. Now this gets a little bit tricky and it's a little bit algebraic in the way we have to solve it, but I'm going to get this x all alone on this side of the equal sign by simply doing the inverse operation here. So if this is 2500ths times x, I want to get that 2500ths away from there by dividing the 2500ths away. That's going to be canceled out. I'm just going to have x all alone. But since I did this over here, it's kind of like a teeter-totter, right? If you're on a teeter-totter with a buddy and your friend jumps off, you're going to fly down to the ground. You're no longer going to be going up in the air. So we've got to keep it balanced, right? If I divided by 2500ths over here, I have to divide by 2500ths over here as well. Now I have 40 divided by 2500ths. Boy, I don't know that one off the top of my head, but guess what I can do? Math. You knew it. So I'm going to take 40 divided by 2500ths. Now remember, whenever I'm dividing with a decimal in my divisor, I need to move that decimal over. That means I need to move this decimal over. I'll add some zeros, and there's my decimal. So 25 goes into 40. That would be 1 time. That's 25. I'll subtract. I end up with 15. Bring down my 0. 25 goes into 150. That would be 6 times. That's 150. I'll subtracting at 0. Bring down my 0. 25 goes into 0 0 times. So it turns out my answer here is 160. So 25% of 160 is 40. And we figured that out mathematically by doing some algebra and a little bit of division work. I hope this video has been helpful for you. Just a brief introduction on how you can solve percent problems.